All right, here we go. Another problem here at the end of solving, and these are going to be tricky problems, especially at the beginning. But after you get a good hang on them, I know that you guys are going to find some good success with these. So here we are going to be undoing kind of our some of the rules we learned at the beginning of the lesson. So if we have two exponents being added, when would we have had that? And hopefully you remember that it's when the base was the same, and then two numbers with different exponents are multiplied together. So really this first part we can rewrite as, well, that must have been 3 to the 2x power times, sorry, not plus, but times 3 to the first power. Again, the base was the same, but two different exponents. And when the base was the same and it was multiplied together, it could have been, or it would have been 3 to the 2x power times 3 to the first power. And we're going to start there and just leave the rest of it all kind of as it is. So minus 10 times 3 to the x plus 3 equals 0. Okay, and just like last time, or actually let's take one more step first. Let's factor out, or kind of divide out our 3 to the x. We've got a 3 to the x here that we're probably going to want to use. And how can we get 3 to the x right here? Well, if it was 3 to the x, sorry, 3 to the x, and then that squared, because remember, if we have two things being multiplied together as your exponent, then the way you would have that is had the power of the 1, or 3 to the x, that exponent, to another power. And so we're undoing these rules right now. So maybe as you're looking around, see what rules you may be able to undo. That's going to be a big skill for you on these type of problems. So we've replaced this part just with our 3 to the x squared, because that would have given us 3 to the 2 times x, and then that 3 to the first power is really just 3 minus 10 times 3 to the x power plus 3 equals 0. Okay, so we've broken down that 3 to the 2x plus 1, and everything else has just been staying the same, but we're just breaking that down. Now, hopefully you can see the thing we have in common here. We've got to finally use it now, that 3x squared, and let's just call that y again. So y equals 3 to the x. We're going to rewrite everything in terms of y. So we have y squared times 3 minus 10y plus 3 equals 0. All right, simplifying this out, we have 3y squared minus 10, or sorry, minus 10y plus 3 equals 0. Factoring that out, we're going to end up with 3y minus 1 times y minus 3. Okay, and it still equals 0. And so we end up with y equals 3 and y equals 1/3. Now, just like we did before, we're going to now substitute y back in for what it was originally, which is 3 to the x. So we have 3 to the x power is equal to 1/3, and 3 to the x power is equal to 3. We just took these two equations with y, and we're replacing y back with 3 to the x power. All right, so now for the first one, if I have 3 to the x power, what would that power have had to have been if we end up with 1/3, or 1/3? Well, a -1 exponent, it was what would do this? It would flip your numerator to your denominator up to your numerator. And so this x is going to be -1. All right. On the other side, if we have 3 to the x power and it's equal to 3, well then 3 to the first power gives us 3 again. And now we have our two x values. We have x equals -1 and x equals 1. All right, so I hope that helped. I know these problems are going to be complicated. They'll be tough for a little bit, but you guys really are going to get quite good at these. You're really going to grow at it, and just hang in there. You can do it.